Continuing in our review of our prerequisite skills, we're going to be looking at linear models and rates of change. We're going to find the slope of a line passing through 2 points. We're going to write the equation of a line with a given point and slope. Interpret slope as a rate or as a ratio or as a rate in a real-life application. Sketch the graph of a linear equation in slope-intercept form. Write equations of lines that are parallel or perpendicular to a given line. So first one, find the slope of a line passing through 2 points. Interpret slope as a ratio or as a rate in a real-life application. Slope, m, of the non-vertical line passing through the 2 points x1, y1, and x2, y2 is m equals delta y over delta x. That triangle stands for the Greek letter delta. That's a capital delta. And that means change in y over change in x. Which another way to look at that is y2 minus y1. That's the change in the vertical distance over x2 minus x1, which is the change in the horizontal distance, as long as x1 does not equal x2. That would be a vertical line. Slope is not defined for vertical lines. The slope of a line can be interpreted as either a ratio or a rate. If the x and y axes have the same unit of measure, then the slope has no units and is a ratio. If the x and y-axes have different units of measure, then the slope is a rate of change. An average rate of change is always calculated over an interval. Coming up, we will study instantaneous rate of change, which is one of the first big things of calculus. First example, I'm going to look at finding the slope of a line passing through 2 points and also interpret slope as a ratio or as a rate in a real-life application. So, Part A, when driving down a mountainside, you notice warning signs indicating that the road has a grade of 12%. This means that the slope of the road is negative 12 over 100. That means down 12 feet, so negative vertical change for every right horizontal change of 100. Approximate the amount of horizontal change in your position if you have descended 2,000 feet vertically. So rise over run is slope. So change in y over change in x. Change in y is down 12 over 100 for change in x. And that should be equal or proportional to negative 2,000, a drop of 2,000 feet vertically, over x. We're looking for that horizontal change. So multiply both sides by x, multiply both sides by 100. We get negative 12x equals negative 200,000. Divide both sides by negative 12. And we get x equals 16,666 and 2/3. I have it written here as a decimal, 0.67, but 0.67 is 2/3 rounded. So that means about 16,667 feet of horizontal change if we dropped 2,000 feet. Part B, the net sales for a car manufacturer was $14.61 billion in 2011 and $16.95 billion in 2013. Find the average rate of change of the net sales over this 2-year period. What will the net sales for the car manufacturer be in 2015? So X equals years since 2011, Y equals net sales in billions of dollars, defining our variables. We got 0.1. 0 years since 2011 is $14.61 billion. 0.2 is 2 years since 2011, so 2013, it's 16.95. So change in y over change in x, so 16.95 minus 14.61 over change in x, 2 minus 0. We get 2.34 over 2, or 1.17. Then we can very quickly write the equation because we know the y-intercept. So y equals m, 1.17x, plus b, the y-intercept, which is 14.61. To figure out 2015, that would be 4 years since 2011. We plug in 4 for x. And so we've got about 1.17 billion per year growth, and in 2015 it would be about $19.29 billion. Next one, write the equation of a line with a given point and slope. Sketch the graph of a linear equation in slope-intercept form. Write equations of lines that are parallel or perpendicular to a given line. So point-slope form, given a point and a slope, we can write our equation as y minus y1 equals m times x minus x1. x1, y1, and m all get numbers put in place of them. And then the y and x without the subscripts will remain there so that we've got the equation of our line. Remember that only non-vertical lines have a slope, consequently vertical lines cannot be written in point-slope form. Slope-intercept form of the equation, y equals mx plus b. M is the slope and the y-intercept is the point 0b. Here we've got the different ways we can look at equations. The general form, ax plus by plus c equals 0. Vertical line, x equals a. Horizontal line, y equals b. Slope-intercept form, y equals mx plus b. Point slope, y minus y1 equals m times x minus x1. Or the one I prefer, y equals m times x minus x1 plus y1. I like it set up where it's solved for y, because then I can plug it into a graphing thing if I need to. So here we're going to write the equation of a line with a given point and slope, sketch the graph in slope-intercept form, and write parallel and perpendicular lines. So two distinct non-vertical lines are parallel if and only if their slopes are equal. That is, if and only if slope 1 equals slope 2. Parallel lines, slopes are equal. Two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. That is, if and only if m1 equals negative 1 over m2. Perpendicular slopes are negative reciprocals. That means if I have slope 1, I need to take that, flip it as a fraction, and change its sign to be the perpendicular slope. The term normal may be used to refer to lines that are perpendicular. Okay, so our second example. Given a line that has a slope of 2 and passes through the point 3, negative 2, we want to find its equation, sketch its graph, find a line that's parallel that goes through the point negative 1, 2, find an equation of a line that's perpendicular that passes through the point 3, 0. So I'm just going to use the point slope form. So y minus y1 equals m times x minus x1. Plug in, I'm actually going to write it as y equals m times x minus x1 plus y1. Plug in m, which is 2. Plug in x1, which is 3. Plug in y1, which is negative 2. Right there, I've got the point slope equation of a line. Most times, I can stop here in calculus. I don't need to go any further. But this does ask for the slope-intercept form, so I just need to simplify that right-hand side. So multiply through by 2, so 2x minus 6 minus 2, so that's 2x minus 8. So there's the point slope equation of the line, and there's the slope-intercept equation of the line. Graphic, we can just plug points that we've got. There's the 3, negative 2, and then can just use the slope up to right 1 or down to left 1, and you can see all the points and draw the line through it. Now for parallel, we want the same slope, so our new parallel slope is 2 also, but we have a different point. So y equals 2 times x minus a negative 1, or x plus 1, and then plus 2. And then I can simplify that to get it into slope-intercept form. So 2x plus 2, so that's y equals 2x plus 4. So the parallel line that goes through negative 1, 2 could be in point slope form, y equals 2 times x plus 1 plus 2, or y equals 2x plus 4 is the slope-intercept form. For perpendicular, we take the slope of 2, flip it, which is 1/2, change the sign, negative 1/2, there's our perpendicular slope, and we repeat the process. This time though, we're going through the point 3, 0. Right there, we've got the point slope form. Simplifying for the slope-intercept form, distributing negative 1/2 times x and negative 3 gets us negative 1/2 x plus 3/2.